Hello, good afternoon to all of you. Once again, I welcome all of you in today's lecture. In the last lecture, if you see the syllabus we have covered what is open channel, then what are the various types of flow in open channel, then the cross sections of the open channel, then we have the another articles, that is the velocity measurement in the open channels. Okay, so in today's lecture we are going to learn the different types of the channel cross sections. We have a rectangular channel, trapezoidal channel, triangular channel, circular channel, and we have certain derivations. Okay, so I am going to share with all of you the today's presentation. Can anybody tell me my voice in the slide is clear? Yes.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. So as far as concerned with the types of flow, okay, we have seen that the different types of the flow. So this is one of the important flow. That's why I am going to recall these types of flow, that is the laminar and turbulent flow. So as far as concerned with these particular types of flow, in the simple sentences, the laminar flow is that types of flow in which the fluid particle do not cross to each other while flowing through the open channel. Then we called it as a laminar flow. Then what is turbulent flow? As far as concerned with the turbulent flow, when the fluid particle flows in a open channel, and when it will cross to each other while flowing, then we called it as a turbulent flow. Okay, but in case of the if you want to define the laminar and turbulent flow in terms of Reynolds number, then how will you define it? So the Reynolds number is equal to rho Vr divided by mu. Okay, so we have the Reynolds number formula, rho Vr divided by mu, where rho is the density of water. The density of water is 1000 kg per meter cube. Then we have the viscosity, okay, that is the dynamic viscosity, mu. Then v is the velocity of flow in the open channel, r is the hydraulic mean depth, and it is equal to the area divided by weighted perimeter. So if the Reynolds number is less than 500, then we called it as a laminar flow. Okay, and if the Reynolds number is greater than 2000, here it is less than, but you have to remember that when the Reynolds number is greater than 2000, then we called it as a turbulent flow. Okay, and when the Reynolds number is in between uh, 500 to the 2000, then we called it as a transitional flow. So depending upon the Reynolds number, we can classify it as a the laminar and turbulent flow. Then also we have seen that the subcritical, supercritical, and the critical flow. So in terms of the Froude's number, if F is equal to V upon, if this is the formula for Froude's number, okay, F is equal to V divided by under root GD. So if the F is equal to 1, then we called it as a critical flow, and F is less than 1, that is the subcritical flow, and F is greater than 1, then we called it as a supercritical flow. Okay, so depending upon the Froude's number, we can classify it as a subcritical, critical, and supercritical flow. Okay, so these are the sketches of the flow which classify as a subcritical and supercritical. We also seen in the last lecture. Then we have seen that the velocity distribution, when the water is flowing through the open channel, how the velocity will distribute it. Uh, so this is the velocity distribution diagram. In case of a rectangular channel or any types of the channel, if you plot the velocity distribution diagram, then the velocity is maximum at the center, and it is gradually decreases at the bottom and at the top. So the velocity is maximum at the center in case of any types of the channel. Okay, so this is about the velocity distribution diagram, and also we have seen that the shear stress distribution diagram. So in case of the trapezoidal section, if you see the shear stress distribution diagram, this is the shape of the shear stress distribution diagram. Okay, so this is the actual shape, and after that, if you consider the shear stress, then this is a shear stress distribution diagram. Okay, then we have seen that. So I request everyone, when entering into the lecture, please remember that mute yourself whenever there is a session for question and answer, or if you have any doubt, then you can ask me. Okay, so we are here how to measure the velocity. Okay, so velocity is measured by the pitot tube. We have also seen that in the last lecture. So with the help of this pitot tube, we can measure the velocity v is equal to root 2 gh. Okay, so this is the simple formula we can use for measuring the velocity. Okay, now with the help of the pitot tube, we can derive a simple formula. How it can derive, we was seen in the last lecture itself. Okay, v is equal to root 2 gh. We have to apply the Bernoulli's equation at section 1 and 2, and also we are going to apply the manometric principle. Okay, and then with the help of the two equation, we will get v is equal to root 2 gh. So in anyhow, you have to remember these two formulae. Then this is the sketch we also seen in the last lectures of the pitot tube. This is a pitot tube, and we have to take h1 and h0 for measuring the velocity. Then how to measure the velocity with the help of current meter, we also seen in the last lecture. Simply a current meter, it is a device by which we can measure the velocity of flow when it is flowing through the open channel or when it is flowing through the river also. So this is the things we was in the last lecture. So in the today's lecture, this is the presentation outline of the today's lecture. So we have the different cross sections of the channel section. So I am going to discuss all the cross section, and how to measure the discharge through the open channel by Chiggy's formula. Then we have the Manning's formula, then Bazin's formula, Kutter's formula. These are the various formulae by which we can measure the discharge through open channel. So let us try to understand what is Chiggy's formula, how we can derive the derivation for the Chiggy's formula. I will explain with the help of the droid cam. Okay, so if possible, I will explain all these things with the droid cam. So I am going to open this particular droid cam so you can see the live sessions. Okay, so okay, here I am having the droid cam. Okay, so basically with the help of this I am going to present but anyhow I am going to enlarge it. Okay, so here so I am going to again set certain things so you can see in better way, better quality. Okay, so let us try to understand the various types of the channel. Okay, so we have the types of channel. The quality is not good. Okay, so wait 2 to 3 minutes so as to I can adjust. So the quality is not so good. Why? The quality of the writing is good or bad? Yes, anybody tell me?
Not visible, sir.
Yes, yes. So why this? What is happening? Okay. Now it is visible. Yes.
Yes, sir.
Okay.
Then
Now, sir, problem will be there. I think regarding about the setting. Okay. So in the next lecture, I will doing the setting of all the things. But uh, anyhow, now it is quite visible. Types of the open channel. We have a rectangular channel section, rectangular. Then we have triangular, triangular channel section. Okay. Then third one is trapezoidal channel section, trapezoidal channel section. Then fourth one is circular channel section, circular channel section. Now let us try to understand the diagram of the rectangular channel section. Okay, the first one is the rectangular channel section, rectangular channel section, rectangular channel section. Okay, so for example, here we have the a rectangular channel section in which the water is flowing for a certain depth. For example, this is the depth of flow, small d. Okay, and we have the bed width of the channel. So this is the width of the channel and this is depth of channel in meter. Okay, all the dimension are in meter. Now here we have the ground level, we have the ground level. So here let us, what is b? B is the width of channel, width of channel, write down in meter, and d is the depth of channel in meter. Okay, now in the first case of the rectangular channel, we have to find out the q. Okay, q is the discharge which is flowing through the channel, discharge which is flowing through the channel in meter cube per second. Okay, in meter cube per second means we have a dam. Okay, and the water is flowing through this channel which is having a dimension b and d. So we have to find out the discharge at any cross section of the channel. So let us try to understand one by one how to find out the discharge in the open channel. Okay, and also one term we are going to learn in this particular derivation in the rectangular channel section, that is the most economical rectangular channel section. So I am going to write the derivations. Okay, so here we have the width of the channel, d is the depth of the channel, and q is the discharge which is flowing through the channel. Now we have to calculate area. Okay, area of channel, area of channel. How will you calculate? A is equal to, so we have the area b into d. So this is the rectangular shape, so area is b into d. Okay, now again we have to calculate the weighted perimeter, that is weighted perimeter, weighted perimeter. We have to calculate next weighted perimeter. Weighted perimeter means what? The area in which water is flowing, submersible area. Okay, so how will you calculate weighted perimeter? P is equal to b plus d plus d. Okay, So this is B, okay, then D, this is D, okay. So this is the submersible, you can say the area, then we called it as a weighted. Weighted means under submergence. So this area is under submergence. So this will be B plus 2D. So this will be B plus 2D. Okay. But what is B is equal to from this area? If you calculate B is equal to from this area, B is equal to A by D. Okay. So from this we will get B is equal to A by D. Therefore, if I calculate the perimeter, then I have to submit the value of this B in this equation. Okay. So A by D plus 2D, because or since, okay, sorry, since you have to write since like this, since B equal to A by D, okay, B is equal to A by D. So this is the formula for weighted perimeter, A by D plus 2D, okay. Now the next things I am going to write here as far as concerned with this derivation. For most economical rectangular section, for most economical, for most economical rectangular channel section, perimeter P, okay, should be, perimeter P should be minimum, okay. So for most economical rectangular channel, for most economical rectangular channel, this perimeter P should be minimum. So what we have to do? We have to differentiate this perimeter with respect to the depth of flow. So differentiating this perimeter P with respect to depth of flow, okay, with respect to depth of flow, okay. So del P by del D, which is equal to 0. So for most economical rectangular channel section, P should be minimum. So we have to differentiate P with respect to the depth of flow. So del P by del D is equal to 0, because what it indicates this equation, because the perimeter is changes with respect to the depth of flow, okay. So
Sir, it is not
I
visible.
am going to put this value del P, the value of the perimeter is A by D plus 2D, okay, divided by del D, which is equal to 0, okay. Now
Sir,
differentiate, yes,
sir, it is not visible, sir. We are not able to see.
but due to the some of the student are facing the problem due to the poor net connection from your side, because uh, in my screen it is clearly visible, okay. Anyone student who are not able to see the screen or the written things?
तर मला पण नाही दिसत आहे सर ते क्लिअर.
सर क्लिअर दिसत नाही, स्क्रीन दिसते पण क्लिअर दिसत नाही लिहिलेलं.
टेक्स्ट दिसत नाही सर ते.
दिसत नाही का? हॅलो,
नाही सर.
नाही सर.
काय
नाही सर.
काहीच दिसत नाही का?
दिसत नाही सर. नाही सर, दिसत नाही.
ब्लर दिसतं सर.
ब्लर दिसतं का?
ब्लर दिसते सर.
यस सर.
ओके बट आजच्या दिवशी आपल्याला हे करावं लागेल. हे काय आम्ही नवीन ड्रॉइड कॅमचं त्याची सेटिंग पूर्ण करावी लागेल आता आपल्याला. तर नाव इट इज विजिबल.
Yes, sir.
Yes.
Yes,
Okay.
sir.
Okay. So see here,
Yes, sir.
del A by D plus 2D. What is this A by D? This is the perimeter we have calculated earlier. Del D which is equal to 0 now. Okay. So differentiate this A by D plus 2D with respect to the depth of flow. So after differentiating this with respect to the depth of flow, I will get minus A by D square plus T. Okay. What I have done here in these steps, differentiating this perimeter with respect to the depth. So I will get minus A by D square plus D which is equal to 0. Okay. Now after this I have A is equal to 2D square. Okay. So take this D square plus D. Okay. So I will get A is equal to this 2D square. But what is this A? A is equal to B into D, area of the rectangular channel. Okay. So if I put the value in this equation, in the above equation, in this equation, what I will get? B into D is the area which is equal to 2D square. Okay, which is equal to 2D square. So B is equal to 2D. Okay, I have got this value for the width of the channel. B is equal to 2D. So what is the meaning of this? What is the meaning of this? The meaning of this equation is that the width should be is equal to twice the depth of flow. So if I write in sentence, the width of rectangular channel, the width of rectangular channel should be twice the depth of flow. So this is the equation for the width. B is equal to 2D. Okay. Now for hydraulic mean depth, okay, I am going to write the another expression, that is the hydraulic mean depth. Okay. So for hydraulic mean depth, which is denoted by letter R or capital M, or we can write or capital M. Okay. So this hydraulic mean depth is equal to A by P. It is the ratio of area to weighted perimeter. So we have to put the area for the rectangular B into D divided by the perimeter is B plus 2D. Okay. So what is this B? We have written earlier B is equal to 2D into D. Again the value of B is 2D plus 2D. Okay. So after this expression we got 2d square divided by 4d, okay, which is equal to, again it is equal to, r is equal to, after this expression I will get d by 2, okay, d by 2. So this is the hydraulic mean depth, that is, it is the half of the depth of flow. So for most economical rectangular channel section, the hydraulic mean depth, that is r, the hydraulic mean depth, that is r, should be half of the depth of flow, okay. So for most economical rectangular channel section, for most economical rectangular channel section, for most economical rectangular channel section, we got two things, that is b is equal to twice the depth of flow. One things we got, that is the width of the rectangular channel section should be is equal to twice the depth of flow, and hydraulic mean depth of the rectangular channel should be half of the depth of flow. This is the second things we got. So remember these two things in case of the rectangular channel section. Width should be is equal to twice the depth of flow, and hydraulic mean depth should be half of the depth of flow. So this is the for most economical rectangular channel section. So what we did in case of the most economical rectangular channel section. So let us try to understand once again. We have a rectangular channel section, okay, in which water is flowing. We have the notation here, width of the channel in meter, and this is the depth of the channel, okay. So here we have the notation again, B and D. Then what is our main objective? We have to find out the discharge in the channel with the help of Chages and Manning's formula, okay. So before going into detail for the Chages and Manning's formula, we have to write two things in case of the rectangular channel, okay. That is, width should be is equal to twice the depth of flow, and hydraulic mean depth should be is equal to half of the depth of the channel. Now here we have the area of channel section. How will you calculate area for the rectangular? B into D. Then we have to calculate the weighted perimeter. So what is weighted perimeter? Weighted perimeter means area under submergence, okay. So here we have calculated P is equal to B plus D plus D. So P is equal to B plus 2D, okay. But from the area we can write here B is equal to A by D, okay. So if I substitute the value in the perimeter in place of the B, A by D, I will get P is equal to A by D plus 2D, since or because B is equal to A by D. So this is the formula for perimeter, okay. This is the formula for perimeter. Now after calculation of the perimeter, we have to remember for most economical rectangular channel section, what is that? for most economical rectangular channel section, the perimeter should be minimum. So we have to differentiate this perimeter with respect to the depth of flow. So if I write in terms of the mathematical expression, so this is the mathematical expression, del P by del D is equal to 0. What is this? The rate of change of perimeter with respect to the depth of flow. Okay. So we have to write here the perimeter. So del in bracket A by D plus 2D divided by del D, which is equal to 0. So after differentiating, I will get minus A by D square plus D, which is equal to 0. But before that, after this, I will get A is equal to 2D square from this expression. But what is the area? Area is equal to B into D. So in the above equation, in case of the equation this, I have to substitute the value of area. I will get B into D, okay, here, which is equal to 2D square. So B is equal to 2D, okay. From the above expression, I will get B is equal to 2D, okay. From this, I will get B is equal to 2D. So what is the meaning of this? The width of the rectangular channel section should be twice the depth of flow. So this condition, the first condition I will get after the differentiation, okay. Then for the next condition, what is the next condition? The next condition is hydraulic mean depth, which is hydraulic mean depth, okay. So it is represented by a letter R or M. So hydraulic mean depth is the ratio of area to the perimeter, okay. So if I write area B into D divided by what is the perimeter B plus 2D, but we have to substitute the value of B. B is equal to 2D into this D divided by value of B is 2D, because twice the depth of flow, okay. So plus 2D. So after this I will get 2D square divided by 4D, and after this simplifying this above equation, I will get R is equal to D by 2. So what is the meaning of this? Hydraulic mean depth should be half of the depth of flow. So this is the case for most economical rectangular channel section, that is the width should be is equal to twice the depth of flow, and hydraulic mean depth R is equal to half of the depth of flow. Then how to find out the discharge, okay, how to find out the discharge. So discharge Q is equal to area into velocity. So this is the general formula for discharge or rate of flow. So I have the area, okay. So area into velocity by Chase's formula. So what is the Chase's formula? What is the Chase's formula? Anybody from diploma? Can you tell me what is the Chase's formula? Anyone? Those are from diploma. Can you tell me what is the Chase's formula? So Chase's, if I write Chase's formula, so it is for velocity v is equal to c under root ri, okay. So this is the Chase's formula, c under root ri, or you can write the Chase's formula for velocity v is equal to c under root mi, okay, where c is the Chase's constant, m is the m or r is the hydraulic mean depth, and I is the gradient or slope of the channel. So if I substitute the velocity in this particular equation, c under root mi, C under root mi. Okay. So C under root Ri. So this is the formula for discharge through open channel, or Q is equal to A into C under root mi. R or M you can write. This is the hydraulic mean depth. You can write M or R. You can represent hydraulic mean depth by M or R. So this is the discharge formula for the rectangular channel section, A into C under root mi, where C is change is constant. Okay, C is change is constant. M or R is the hydraulic mean depth, and I is the bed slope of the channel section. So this is a simple derivation in case of the rectangular channel sections. Okay, this is the very simple derivation for the rectangular channel section. Now, first we have to find out the width and depth of the flow by taking a small problem for the rectangular channel section. Okay. So I request all the student, please write one problem. Okay. You have to also write one problem. Are you ready for writing the problem? Yes.
Yes, sir.
Okay. So okay, write the problem, first problem on the rectangular channel section. A rectangular channel section, write down a rectangular channel section, a rectangular channel section in which water is flowing. I request all the students, please write down this formula, this problem, in which water is flowing at the rate of 400 liter, okay, per second. Okay, when bed slope is 1 in, when bed slope is 1 in 2000. Okay, find the most economical dimension of the channel. Find the most economical dimensions of the channel. Dimensions of the channel. Take C is equal to 50. What is this C? Change is constant. Okay, take C is equal to 50, that is change is constant. So this is the problem. Okay, this is the given problem. What is this problem? A rectangular channel section in which water is flowing at the rate of 400 liter per second. The discharge is given. When bed slope is 1 in 2000, find the most economical dimension of the channel. Take C is equal to 50. Okay. Now we have the solution. Okay, we have the solution. Now as far as possible in examination, you have to write down given data given data, whatever may be the data is given in the problem, you have to write first what is given. The rate of flow, that is discharge, is given. How much it is? 400. This is given 400 liter per second. Now you have to convert this liter per second into meter cube per second, that is 0.4 meter cube per second, because 1 meter cube is equal to 1000 liter. Okay, so we have to divide by 1000, so you will be get 0.4 meter cube per second. What is the next thing which is given itself in the problem? Bed slope is given. Bed slope, okay, bed slope is given, that is I is given. How much it is? 1 in 2000. Okay, the bed slope is given 1 in 2000. Again, the changes constant is given. Changes constant is given, that is C is equal to 50. Okay, C is equal to 50. Now what we need to find out? We need to find out the most economical dimension, that is what should be the bed width of the channel and what should be the depth of flow in the channel. So first we need to find out the bed width of the channel and the depth of flow. So how will you find out? For most economical rectangular channel section, we have to write for first condition, for most economical channel section, B is equal to twice the depth of flow. Okay, and the R is equal to half of the depth of flow. So this is the first case and this is the second case. So therefore A is equal to B into D. Okay, so what is the value of this B from the equation 1? 2D. So we have to substitute 2D into D. So 2D square. So area is equal to 2D square. Now apply according to Chase's formula. According to Chase's formula. According to Chase's formula. What is the Chase's formula? Q is equal to AC under root Ri. So this is the Chase's formula. AC, area, into velocity. What is the velocity? C under root Ri. Okay. So we have the discharge, we have the C, but we don't know area Ri. Okay. So if you simplify it further for this particular example, you will be get Q is equal to AC under root Mi or Ri with the help of Chase's formula. Okay, R or M. So write down 0.4 is the discharge which is given, area 2D square into value of C is 50 which is given in problem itself, and what is this M? This is D by 2. Okay, half of the depth of flow into I is given 1 is to 2000. So we can write in this way. Then further if you simplify this equation, so 0.4 which is equal to 2 into 50. Okay, 2 into 50 into under root 1 divided by 2 into 2000 multiply by d raised to 5 by 2. Okay, d raised to 5 by 2. So this is the simplified equation. Then 0.4 after simplification. After, if you simplify this, can anybody tell me what is the value of this? 2 into 50 into under root 1.581 d raised to 5 by 2. Okay, d raised to 5 by 2. So again, if you want to find out this d raised to 5 by 2, which is equal to 0.4 divided by, if you take on the left hand side, then 1.581. Okay, then d raised to 5 by 2, which is equal to how much? It is
0.253.
0.252.
0.253. Okay, then d is equal to now 0.253 raised to 2 by 5. Okay, 2 by 5. Now calculate d is equal to how much it is?
0.577.
Okay,
0.577.
0.577 meter. So this is the value of depth we will get after simplification. Okay, and we have to calculate again width. Okay, so bed width of the channel, which is equal to twice the depth of flow. So we have the value of this depth of flow, so simply multiply by the depth of flow 0.577. So how much it is?
1.154.
1.154 meter. So B is equal to 1.154 meter. Okay, so we have got the value of the bed width and the depth of flow for a rectangular channel. Okay, for a rectangular channel, provide bed width B is equal to 1.154 meter and D is equal to 0.577 meter. So this is the uh, bed width and the depth of flow for a rectangular channel section. So this is a simple problem. So a rectangular channel section is there in which water is flowing at the rate of 400. Okay, so some of the students are doing mistakes here. The liter per second is given, sometime this is given in liter per hour. Okay, LPH. So we have to convert into meter cube per second. Okay, so 1 meter cube is equal to 1000 liter. Remember, again, when the bed slope is 1 in 2000, find the most economical dimensions. So most economical dimension means what? We have to find out the B and D. We have to find out B and D. And also given the changes constant C is equal to 50. So first we need to write whatever may be the data is given itself in the problem. So the data is given a rate of flow, so 400 liter per second. So we have to convert into meter cube per second. So how will you convert it? Divided by 1000. So we will get 0.4 meter cube per second. Bed slope I is equal to 1 in 2000. Changes constant C is equal to 50. So we have to find the most economical dimension, that is B and D. Okay, so we have the two condition for most economical channel section. So the first condition is B is equal to 2D, that is the width is equal to twice the depth of flow, and hydraulic mean depth R or M, the half of the depth of flow. So this is the two condition we have got earlier in the derivation itself. Okay, so we have to apply these two conditions. Now area is equal to B into D. So what is the value of B here? 2D. So 2d into d, so area is equal to 2d square. Now we have to apply the Chase's formula. We have to apply the Chase's formula. So what is the Chase's formula? Q is equal to area into velocity. So this is the velocity by Chase's formula. So this is the velocity by Chase's formula. C under root Ri or Mi. Now only what we need to do, we need to substitute the value and we have to simplify it. So discharge is 0.4, area 2d square, the value of C is 50 into R or M is d by 2, okay, for the most economical rectangular channel, and we have to substitute the value of the slope or the gradient, okay, 1 by 2000. So simplify this, you will be get 0.4 which is equal to 2 into 50 into root 1 by 2 into 2000 into d raised to 5 by 2, okay. Now further if you simplified it, you will be get 0.4, the value of this whole expression you will be get 1.581 d raised to 5 by 2. So d raised to 5 by 2 which is equal to 0.4 divided by 1.581. So d raised to 5 by 2 which is equal to 0.253, then we will get, after simplifying this, after calculation you will be get the value for the depth of flow, that is 0.577 meter, and area is equal to B is equal to 2d, okay. So simply we have to substitute the value of d, earlier we have calculated, you will be get B is equal to 1.154 meter. So for most economical or for the rectangular channel section which is given in the problem, provide B is equal to 1.154 meter and D is equal to 0.5777 meter. So remember that for the discharge 0.4 meter cube per second, we have to provide the dimension B is equal to 1.154 meter and D is equal to 0.577 meter. So this is the things we got, okay. So this is the value we got in this first problem. So I am going to give one homework. So please write that homework. Are you ready for writing the homework? Yes?
Yes,
Yes,
sir.
sir.
Okay. So I am going to give one homework. So we have the homework here, okay. So find the velocity of flow and the rate of flow of water through a rectangular channel of 6 meter wide and 3 meter deep when it is running full, okay. The channel is having the bed slope as 1 in 2000. Take Chase's constant C is equal to 55. The second problem, find the bed slope of the rectangular channel section of width 5 meter when depth of flow is 2 meter and the rate of flow is given as 20 meter cube per second. Take Chase's constant C is equal to 50. So these are the two homework problem for you. In the next lecture, I hope you will be there in tomorrow's, day after tomorrow's lecture with the all answers, okay. I hope so. So you can take a snapshot also for this particular slide, and remember that I would like to give one instruction. Please make a separate notebook for this particular subject. So whatever may be the things we are going to cover, you have to write in that particular hydraulics 2 notebook, okay. So day by day you will find that all the things are very simple if you follow the instructions. So please make a separate notebook. Whatever may be the things we are going to cover day by day, you have to write all the things in your that notebook. So this habit will make you people very, you can say, uh, you can say the having a more knowledge in case of your hydraulics too, if you follow that instructions. Okay. So have you written this particular problem? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So today we will stop
Yes,
here.
sir. Yes, sir.
I am going to download the attendance as well. So again, thank you very much for coming in the today's lecture. I hope the